Hello and welcome back to the PopcornFX channel. In this tutorial, we're going to show you how to create this abstract fire by using spatial layers to create the Plexus effect. We use spatial layers to enable particles to interact with other particles. That can be in the same layer or from a different one. Let me show you guys the shaded wireframe of this to display how cool it is. I'm going to disable the other layers and keep the base of the effect for a better visual. Now that they are out of the way, I'm going to pause this and zoom in over here. As you can see, these are two particles connected by a line. This looks like a neat sculpture over here. So cool. This is wireframe mode without color. Let's put this back to normal speed and put the rendering back to normal. And there we go. I'm going to explain the logic of how we did this. By using spatial layers, we're going to tell each particle to search for another particle within its radius. If it finds one, it's going to connect it with a line. But the line is actually another billboard, with its mode set to velocity capsule line. I'll show you. We'll click on link 1 to check out the billboard mode. Now if you're looking for more info about this, all you have to do is just go to the Popcorn Wiki. Ladies and gentlemen, I present to you the Bible of PopcornFX. If you need any information about PopcornFX, you can find it in here. Anyway, let's check out the billboards. Then go to velocity capsule line. So it's like the other axial billboarders, but this one is not limited to the velocity alignment and can use any other axis for billboarding. I forgot to mention that I've used the same texture for the line and the dot. As you can see, they're all the same. But the question is, how do we set the axes and positions of these billboards so they would look like this? Let's go to the drawing board. Let's imagine that this is our particle system. We'll start by this particle. We'll name it A. It's going to search its surroundings within a limited radius to find the first closest and second closest particle. The first closest is B, and it's going to be connected to it by a billboard. Let's call it K. K's position should be the average of the positions of the particles A and B, and its axis should be the position B minus position A. So, in conclusion, K's position is going to be the B's position plus A's position, all divided by 2. And K's axis is going to be B's position minus A's position. As for the C particle, it's going to connect to A with L. And all is going to follow the same logic. The position is going to be the average of the positions, and the axis is going to be the difference between them. And now every particle is going to do the same thing. Find the first and closest particle and connect them. This one will connect with A and B. This one will connect with A, then the one in the bot. We already did A, then B is going to connect with A, then C is going to connect with this one, then B, and this one is already connected with C. However, this final particle is too far from the other particles, so it doesn't connect with any of them. It's the forever alone particle. Alright, now that that's done, let's create a new effect. And call it Fire Plexus Tutorial. Here we go. Let's disable the looping. Set the spawn to infinite and make it spawn 35 particles. Then we reset the effect by pressing Ctrl R or just click on this icon over here. Now we have the particle spawning in the same place. To fix that, we're going to let it spawn on a shape. So we're going to create a new shape, set it to sphere, then change the radius to 0.35. And in the spawner script, we set the initial position by typing position equals shape1 dot sample position. Ctrl Enter. Now we have the initial position of the particles spawning on that shape we just sampled. And this texture is annoying us, so I'll change it to this one. Looking good. Now we're gonna set up the spatial layers. We right-click on spatial layers and add new spatial layer. And we'll name it Plexus. Fire Plexus. Afterwards, we'll add a spatial insertion evolver to the evolver script. And select Fire Plexus. We're also going to need the other billboards. So I'll rename this one to main points. Duplicate it. And rename it to link 1. And change its settings, position to position 1, size to size capsule, and set the mode to velocity capsule align. Change the axis field to axis 1 and set the axis scale to 1. The red here is normal. It's because we need to add the variable axis 1 to the fields. It's a float-free variable. I'll duplicate link 1, then rename it to link 2. Set the axis to axis 2, position to position 2, and add the variable axis 2 to the fields to make everything fine and dandy. Now, since we're going to be changing the attributes of the particle every frame, it means that we're going to need an evolver script. So let's add that. And now we're going to be needing the spatial layer functions. To check it out, we're going to go to the internet browser. Or we can try this. We right-click on the spatial layers and click on documentation. It will get us to the wiki page where everything is explained. But we'll be going to the script reference and we'll search for spatial layers. We'll be using this function. So we'll copy it. By the way, this function returns the value of the field name that we input if it finds the particle. If it didn't, it's going to give us an infinity value. We're going to keep this in mind for later. Let's go back to Popcorn, pass that function in the evolver script, and assign it to pause 1. Change the layer name to the spatial layer name, which is Fire Plexus. The field name we're looking for is position. As for the center, it's going to be the particle's position. For the radius, we're going to create that attribute over here. Name it radius with a capital R. Change the value. Let's set it to 0.8 and save it as default. And set the closest to 1. Now we're going to have to check if the particle is going to find something in the query. So we'll be using the select function to check if it's an infinity value or not. Select takes three inputs, two variables or values, or even functions, and a condition. If the condition is true, it's going to return the second input. If it's false, it's going to return the first. So if the pos1 is not infinity, meaning that this condition is true, we're going to use pos1. So we're going to put it in the second input. So if the pos1 is not infinity, meaning that the condition is false, we'll be using position. So we'll put it in the first input. As for the axis 1, it's going to be position minus p1. Forgot to assign the position. As we said, it's the average of both positions. So we'll add them up and divide them by 2. Ctrl Enter to compile. Whoops, typo here. Ctrl Enter. There we go. Of course, nothing is going to show up since we didn't set the size of the capsule yet. We'll copy the variable name and paste that in the spawner script. Put in 0.05, Ctrl Enter, and here's the magic. Gonna resize the main points a little bit. What's left to do is the same thing to link to in the evolver script. So I'm going to copy this and change the variables. Pos1 to pos2, the second closest particle, the second closest particle, the p1s to p2s. Here we go. Axis 1 to axis 2. Ctrl Enter to compile the script. Now we'll add a little bit of turbulence to give it more life. Apply the turbulence in the physics. Set the drag to 0.1. And tweak the turbulence values a little bit. Maybe also add a timescale. Change it to 0.5. And here you go. That's a sexy effect that needs some color pimping. So we'll add the evolver field modifier. And choose color. It's going to disappear. It's normal because the curve values are set to 0 by default. So let's select the first point, press C to open the color picker. Put in the color values, increase the expose, let's set it to 12. Didn't apply that. Click C again and set it to 12. Then Alt-Shift click somewhere else on the curve and set the time to 0.25. Press C and set the expose to 4 and decrease the transparency. Set the color value of your choice and then click OK. Select the last point, press C, set the transparency to 0, it's already set here, and then set the color to the color of your choice. Click OK. Gonna readjust the second point's value. Seems that it didn't apply before. Alright, this is looking better. What we're doing next is that we're going to adjust the size of the lines over time. So we'll change the initial size in the spawner script. We'll go to the spawner script and change size capsule to size capsule coef. Ctrl Enter to compile. Add this variable to the fields as a float. Now we need to set the size capsule. So we're going to add an evolver field modifier first. Move it on top of the evolver script, choose size capsule, and change the curve. It's too big because we didn't adjust the code yet. So we'll go to the evolver script and change the code. We'll put in size capsule coef multiply equals size capsule. No, it's actually the other way around. It's size capsule multiply equals size capsule coef. Ctrl Enter and witness the lines decreasing in size. We can do the same for the points too, but we'll use the size coef instead. So I'll fast forward this since it's the same. I also want to stress that the order of the evolver fields is really important, because over here we take the value set by the evolver field and multiply it by the coefficient. On the other hand, without the evolver field, the size from the previous frame would be multiplied by the coef every frame. Alright, this looks good. Let's make this more dynamic by changing the initial lifetime of the particles. To do that, we'll go to the spawner script and multiply life by random 0.8 and 1.2. Actually, let's change this to 0.5. Copy that and paste it to adjust the velocity too. It's not that intense. So maybe we can multiply it by 2. And we got ourselves the beginning of a very, very sexy effect. Almost forgot, we also have the radius exposed to the game engine. And we can change this value by code in the game engine. And even in Blueprint when it comes to Unreal 4. There are limitless ways we can use the spatial layers, and there's a lot that we can do. Even on the same effect. It's really fun to test it out. So that's gonna wrap things for our video. Don't forget to like it if you found it helpful, and subscribe for more tutorials. And like always, thank you for watching.